everybody. My name is Holly Grafbaum, and I'm an MLTI ambassador. And today I'm going to talk to you about problem based learning. What is it, and why is it important? I would like to also recognize that this particular video is going to be part of a series of modules that I'll have on problem based learning. I'll be talking about some tech tools that you might incorporate as you are using problem based learning in your classroom. I will have a module on design thinking and a literacy approach. And I'll talk about physical computing and computer science. I'll look at computational thinking and how it relates to design thinking and the engineering design process. And finally, I'll wrap up talking about makerspaces and their connection to problem based learning. So again, my name is Holly Grafham. I'm an MLTI ambassador. Prior to coming to MLTI, I was a technology instructional coach at Scarborough Middle School for the last 6 years. I've included my email address, my Twitter handle, and a link to the MLTI YouTube channel, which is where this video and other videos presented by the ambassadors will live. There will be in the description under this YouTube video, you should see a link to the PDF of this slide deck that will have all of these links that you can access and other links that might be there throughout this presentation. So what is problem-based learning? PBL is an inquiry-based approach that utilizes an interdisciplinary design to find solutions for real-world problems. It applies to any content area. It involves authentic real-world problems. It explores multiple pathways to solutions, generates a plan based on the best solution, creates solutions and prototypes that may be theoretical or tangible, and students communicate their findings to others. If this is starting to sound familiar for any of you that look at any of the design thinking processes, you'll kind of start to see a pattern here. And so why is it important to have in your classroom? PBL promotes and provides students opportunities to practice critical thinking skills, problem-solving abilities and strategies, communication skills, and creativity. And if you ask any employer or any higher education institution, like what are the things that they are looking for in their students, these would be the top skills. And so even if you are a pre-K to grade 12 teacher, it doesn't matter. Students need practice in all of these skills. And so at every grade level, we should be giving them opportunities to do that. Some of the benefits of problem-based learning are for students is that it is very engaging. It is student-centered. It develops real-world skills. It allows for student agency of their learning. It activates content knowledge and requires students to utilize reflective practices and communication skills. So what is your role as a teacher? I've kind of talked a lot about this being student-centered, but what is your role? Your role as a teacher is to provide content context. You're to create an environment in your classroom that is a fail-forward atmosphere, to provide feedback to your students, to anticipate possible resources that students may need, and to scaffold learning of new tools, especially technology. So what does the problem-based learning process looks like? Well, first of all, you'll notice that this is a ongoing process that is not a linear, but a fluid situation. So, but if we had to start at the beginning, we would look at the problem. Students examine or identify an open-end, authentic problem. This could be something that the teacher provides, or it could be something that the student wants to investigate. And once you've identified this open-ended problem and you've examined it a little bit, and that might include research, then students need to ideate. So at this point, they're going to work collaboratively to develop a plan and a brainstorm. They're going to generate a list of possible solutions that might solve this problem that they have been examining, exploring, and identified. Once they've got generated this list, they're going to look at the list and they're going to pick the best possible solution to test. Then they will implement and test. So students investigate to see if their plan solves the problem. Students may generate prototypes, models, and other products in this process. So they may actually build physical things, but it might be something that is more theoretical, like a public service announcement. But whatever it is, they're going to develop a product that tests out their solution that they have for their idea. Then they're going to evaluate and iterate. So students are going to analyze results, reflect, and make changes if necessary. And this might take several iterative cycles. This is where the feedback is absolutely vital. Peer feedback, teacher feedback. You could get outside of the classroom feedback. And again, regardless of whether or not this is a tangible product that they built or something that is more theoretical, the idea is to have somebody else look at this and provide suggestions, point out areas of improvement, and the like. So once students go through this iterative process more than once, so it shouldn't just be one time. They go in, they get their feedback, they make some changes, they test again, they may get more feedback, and then make some changes and test again. How long that cycle goes is something that you'll have to determine in your classroom. Time constraints may have a lot to do with how much the iterative process lasts. But once they've gone through that cycle to a certain degree, they're going to then share their results. So this is what we have learned about our idea to solve this problem. So this is very student-centered problem-solving process. The teacher is really there to facilitate, guide, help provide some feedback. This might be where you would provide resources for students, help them find the resources that they might need as they go through this process. And if that process looks familiar, is because it is very connected to some other processes that you might already be aware of and implementing in your classrooms right now. And the first being the engineering design process. Again, if we look at that, this is just one. There are, again, multiple vocabulary that and some of the steps might be fewer or more, but this is pretty much the it's a good representation of the engineering design process. You define a problem, identify constraints, brainstorm, select the best solution, build a prototype, test it, iterate, make some improvements, iterate again, make some improvements, and communicate your solution. This one happens to come from Engineering for Good, which I really like, and this is the one that I use in my classroom when I was teaching engineering design process. The other thing about this, for those of you that are looking like, how can I connect this to my standards? Well, if you look into the Next Gen Science standards, there is some standards around engineering, and this certainly would fit into that. This next one that I'm going to look at is the Stanford design thinking process. The Stanford D School is the one that really kind of was the front pioneers in design thinking, and their model's a little different, but it is again very similar to problem-based learning, very similar to the engineering design process. It really the difference being about the empathizing. So at this, in the research part of whatever you're doing, in your problem solving, interviews, looking into how the user end of whatever it is that you're doing, what their experience is going to be. Not to say that that can't happen in these other processes, but they put a unique emphasis on this. So they do that part at the beginning, then um, they define a idea, they define their roles. I'm not going to read all of this, but then they ideate. So then they, um, how can we share our ideas? What are the brainstorming pieces? They develop a prototype, and then they test that to see if it works, and they do some iteration. So again, a little bit different, but very similar and connected to these other processes. And finally, the model that you're probably all most familiar with would be the scientific method that I have here up on the left. But if you look at the right, I've also created a model here of scientific inquiry. So the scientific method is a very linear model. While it does have a lot of the same elements of the problem solving process and the other processes that we've been looking at, it's very linear, usually answers a single question, and the results are communicated at the conclusion of the experiment. Sometimes, if your hypothesis is incorrect, you might go back and try that again, but that's not a guarantee. So, but if we look at scientific inquiry, that's a little bit different. We can see that that is nonlinear. That is a fluid situation. Looks very much like these other processes we've been looking at. It may end up generating more questions, and communication is key component throughout. And there is this iterative process that happens when you are um, testing and gathering data. You might decide that you get the data back, you analyze it, and you might decide you need to tweak your experiment a little bit and to get better data. And so you do that iterative process again. That could go on, but eventually you're going to stop with that. And then you share your results. Often that leads to another observation, another question, and the cycle goes on and on. So when you're thinking about designing a lesson around problem-based learning, so what are the key elements, what are the key components that you should be having in your lesson design? So first and foremost, your lesson should call on content knowledge. I just recently was at a great workshop where I had a very big aha light bulb moment, where the presenter talked about how we shouldn't be teaching content and technology at the same time. Students need to be familiar with one or the other, right? So students should either have a base in the content knowledge and you are activating that, which is the case that we're going to talk of here in this problem solving, or They should have a basis in the technology that you are using or the process that you are using. Um, and then they're using that process, they're activating that knowledge. So again, either having a basis in the content or a basis in the process you'll have a much better outcome than if students are trying to learn this process and learn new content at the same time. So calling on some content knowledge, again, it could be content as in whatever curricular content you teach, or it could be technology content, or it could be the process content that we've been talking about. Um, and I provide a pretty good example of that when we're talking about design thinking is a literacy approach. I'll kind of talk a little bit about that. It needs to be relevant to the learner. So, if, for as much as you can let students be involved in this process, looking at generating ideas of problems, uh, self selecting problems that they want to try to find solutions to. Obviously, the more relevant the topic is to them, the likelihood that they have increased engagement. They need to be authentic and open-ended problems. They shouldn't have just one solution, or there should definitely always be a variety of solutions. Um, and they need to be able to share these results with others. So make sure that when you're developing your lesson, that is built into it. The sharing piece is built in. Uh, I would make sure that the lesson uses an interdisciplinary approach. Students should be using research skills. They should be writing. This is if it's in math or science or whatever class it is, they should be able to activate all of these skills that possibly they learned in another content area than what you are currently teaching or using this lesson in. But make sure that you are kind of looking at a interdisciplinary approach. They need to have access to digital and concrete material. If one of their solutions involves, building something tangible, make sure that they have access to materials to build prototypes. If it is going to be something that's more theoretical, like a public service announcement, make sure that students have access to the technology that's going to allow them to be able to do that. And then finally, give sufficient time to the process. So, depending on what it is that you want them to do with this, it's probably not going to be a one lesson off kind of thing to do problem based learning. It could be, but it's probably not going to be. It typically is something that is more of a long term. I don't want to use the term project here because I don't want you to confuse problem based learning with project based learning. Um, Often there is a project that is part of the problem-based learning, but the learning doesn't come from the project itself it comes from the process of solving the problem. So along the way, you're going to need some documentation, like, how are you going to assess students formatively, summatively, and provide them feedback. So I look at documentation as there are two different pieces and potentially three different pieces if you want to look at that of documentation that students are going to be needing. First of all, they should be documenting the process. So something like an engineering notebook, and I use that term engineering. If you feel like that's too sciencey, you can call it a design thinking notebook or whatever the term it is. But where you have a graphic organizer, if you will. I happen to use uh, a slide deck or with Google Slides. That's just my preference. But something that students can be filling out each step of the process as they go, and that you will be able to also have access and look at that and provide feedback and assess their learning. So you, and it might be a project planning tool, whatever it is that you're most comfortable in your classroom there, but there should be some process documentation that students do throughout the whole problem solving um, plan lesson. I recommend that they be digital if possible, because digital offers students the ability to add beyond text. They can take a picture of what they're doing. They can create a video. They can make audio notes. This is very helpful for students, especially if there is, in my classroom, there might, I only saw students once or twice a week. So there often be big gaps in between where um, and working in this project, and for them to be able to go back and look at the documentation that they had of where they were at the last step of the project was very helpful. I also just think it's another way for to provide even more information than you could if you just wrote something down. And for some students, it's a lot easier. They can convey their learning and their messaging a lot easier through these digital formats. I'll talk a little bit about reflection logs, which is another during the process thing in the next slide deck. But the other piece of documentation is the solution presentation, right? So you there document the process. These are the steps that I've gone through. This is what I did in the brainstorming step. And so maybe it's an image of my brainstorm that I've attached into this. But I also need a way to, at the very end of this process, to present my solution, to share my solution with others. If at all possible, to offer choice or a choice menu is for students to demonstrate their learning is, I feel like, the best way to go. Choice and voice gives students agency and lets them call on their strengths. Um, Also, different solutions might be suited for different presentation formats. And I'm going to talk a little bit about assessment, because you're being like, well, how can I create rubrics for 100 different projects and um, all of that? But we'll talk about assessment and what I think are the most important parts about the assessment that really do lend itself to choice menus and student self selection of how they want to present their learning. And so here we are, we're talking about assessments. So, first of all, I think rubrics are the way to go with this. Remember, this is an open ended um, process. There's not one right solution. So, I think it is most helpful if you have rubrics that focus on the use of the design process, documentation of their learning, the authenticity and the creativity of whatever their solution is, and then their presentation skills. Were they be able to, did their were they able to demonstrate their learning through however they presented their solution? And you can see that if you focus on these qualities of the problem based learning process, you don't have to have a specific rubric like every student had to have, 3 images, and every student had to have a slide deck that did A, B, C, and D. Again, maybe a slide deck is a great way to present one solution, but if you have a student who is building something, maybe they need a different format to present that solution. So instead of focusing on the correctness of their product, I would focus on these design processes instead. Authentic solutions, the solutions that they generate should be plausible and authentic. So that is definitely something that you would include in your rubrics. For instance, when I talk about using design thinking in the literacy classroom, and students are generating products that are based on a problem that is within a novel, the solutions have to be plausible and authentic to the characters and setting of the novel, or it's just not believable. So that is one thing to keep in mind. You should have formal and informal formative assessments, and they should be given to the students throughout the process. And this is where I really talk about reflection logs. One of the things that I found is I was doing this, and I've done this in different classes with different assignments, is that uh, having the documentation of of them going through the processes wasn't necessarily enough. I wanted some more daily feedback from students, and the reflective assessment logs really were helpful with that, and was able for students to um, talk about what's going well, what's not going well, what what's my plan for the next time I'm going to work on this project, do I have any questions, that type of thing. And it allowed me to really provide students with targeted feedback that they really needed. And then you want to score separately the technical aspects such as writing, grammar, and attention to detail. Again, I think that those are super important when students are presenting products. When we're talking about gaining real world skills here, you can't, get up and present things that have a lot of technical and grammatical errors. And so I think it's definitely appropriate to look at those, but that should kind of be separated from whether or not the student used the design, the problem solving process correctly, and the authenticity and the creativity of their design and their product. So I like this raft approach to assessments. And I just alluded a little bit in the formative assessments around feedback, because feedback throughout this process is key. Students should be recording and sharing frequent and reflective feedback. This is recording in their engineering notebook. This is recording in their reflection logs. This provides the teacher an opportunity to interact with the student in a much more individual way. Again, if it's digital, I think that just makes it all that much more easier for the student and the teacher to have access to that in a more timely fashion. And so teachers should be providing frequent, timely, and targeted feedbacks to students. Uh, and peer feedback should also be incorporated into the iterative design. Do not think that you have to be the one and only looking at this. You're going to get it to a point in the process where students have, created some prototypes or some products, and they need some additional feedback more than just what you can give this. And this is a great time to have some peer feedback, uh, built-in feedback time. And I often use this uh, this acronym TAG when I'm doing peer feedback. I'm sure there's a million other different ways to describe the same process, but when I have students do peer-to-peer feedback, they use this protocol of tell me something that you like, ask me a question about what I've presented, and then give me a suggestion for improvement. I think using a very strict protocol to this gets away from is much more targeted. So students are like, oh, well, that was great, or this was great. It's like, no, tell me something that you liked about this. What is a question that you still have? Give me a suggestion. It allows both the person receiving and giving the feedback a much more focused and concise um, protocol. So all of these things should be fitting into your lesson planning. So I'm going to talk a little bit here about the contact hour, but just to kind of give everybody an overall picture of what a problem based classroom kind of looks like. It's very student driven, student centered. Students are working individually in small groups and on their own individual ideas, developing solutions to problems. The solutions aren't all going to be the same. The problems might not even all be the same. That's something that you can also think about and determine. And you, as a teacher, you're there to make sure that they're staying on track with um, with their with their activity, their problem-based problem. They are you're providing feedback for them. You're helping them iterate in their design. You may need to help provide resources as they identify, I think that we could build such and such a thing, but I don't know how to make a movie. And so you might provide some resources on how students might do that. So that is sort of the teacher role, is to be much more of a facilitator of the learning, because hopefully you have already done the direct teaching of either the content or the process or the technology that you're using. That has all been done ahead of time, and students are really just activating that knowledge at this point. So I'd really like to thank you all for taking some time to watch this video around problem-based learning. Um, if you again, this slide deck is in a PDF format. Um, in the description. And if you click on the link on this last slide here, you can get to a form that you can fill out for. It has a few quick questions, and you'll be able to get your contact hours from there. I hope that you join me as I go move on to the other modules um, in this series around active learning, and have a great day.